The search theory of money, pioneered by Kiyotki and Wright, 1989, provides a micro-foundation for why money exists. Unlike other models that simply assume money has value, like the money in the utility model, search theory derives the value of money from trading frictions. It explains money as a tool to overcome the double coincidence of wants problem in a decentralized economy. 1. Key elements of search theory. Decentralized trade. Agents meet randomly in pairs. There is no central marketplace or auctioneer. Double coincidence of wants. In a barter economy, trade only happens if I have what you want and you have what I want. This is statistically rare. Specialization. Agents produce a good they do not consume and consume a good they do not produce. Friction, search costs. Finding a compatible trading partner takes time, which is costly because agents discount the future, R. Fiat money, an intrinsically useless, storable object. It has value only because agents believe they can trade it for goods in the future. 2. The mathematical model. To derive the value of money, we look at an economy with M, fraction of agents holding money. 1M, fraction of agents holding a commodity, producers. Alpha, the matching rate, how often agents meet. X, the probability of a single coincidence, the probability that a random agent produces a good you desire. U, utility from consuming your desired good. C, cost of producing a good. R, the discount rate, interest rate. Step 1. The Bellman equations, value functions. We define V_1 as the expected lifetime utility of holding money and V_0 as the value of holding a commodity. The value of money, V_1, an agent with money meets a producer with probability, 1M. The probability that this producer has the good the agent wants is X. If they trade, the agent gets utility U, gives up the money, and becomes a producer, V_0. The value of production, V_0, a producer meets a money holder with probability M. The probability the money holder wants the producer's good is X. If they trade, the producer gives up the good, receives money, V_1, and incurs a production cost C. 3. Mathematical derivation of the value of money. We want to find the liquidity premium or the net benefit of moving from a producer state to a money holder state. Let delta equals V_1 V_0. Step 2. Subtracting the equations. Subtract the expression for RV_O from RV_1. Substitute delta equals V_1 V_0. Step 3. Grouping the delta terms. Move all terms containing delta to the left side. Factor out delta. Step 4. Solving for delta 4. Economic interpretation. The acceptance condition. For fiat money to be a medium of exchange, an agent must prefer holding money over their produced good. This requires the gain from trade to be greater than the cost of production. If we plug our derivation into this inequality, simplifying this, multiply by R plus alpha X and rearrange. Interpretation of the results. The role of U_C. Money only works if the surplus from trade, UC, is high enough. If the good is hard to make and provides little joy, money won't emerge. The role of R. If the discount rate R is too high, agents are very impatient, they won't wait to find a trade. Money loses its value because the wait time for the next partner is too costly. The role of alpha X. If the meeting rate or the probability of a want, X, is too low, the search friction is too high for money to be viable. Social convention. This model shows that money has a self-fulfilling property. If M is 0, no one carries money, the value of holding money, V_1, becomes 0. Money only works because everyone else accepts it. Comparison with barter. In a pure barter version of this model, an agent would need to meet someone who has exactly what they want and wants exactly what they have. The probability of trade would be x squared, which is much smaller than x. Money effectively increases the frequency of trade by turning a double coincidence problem into two single coincidence events. Would you like me to show how this model changes if we introduce storage costs for different types of goods?